We have the equation V equals negative n and then d flux over d time. We have our givens up to the right. We have B max is there and our omega. We have the equation flux is equal to B times the area, B being the magnetic field. And they also give us the equation of the magnetic field. B is equal to B max sine of omega t. So what we're going to do is we're going to solve for flux and then take the derivative in order to plug it into this equation. So right here we have that flux is equal to the B max up here, which is 2 times 10 to the negative 6, times the area, and then times the sine of omega t. Now we want to take the derivative in order to fit this into the equation. So we're going to take the derivative. You're going to get the normal equation, make sure you do chain rule and times by your inside function, which is going to simplify down to flux dt is equal to 0.0018 cosine of 3 times 10 to the negative 10 to the 6 t. Now plugging that back into the equation, you're going to have V is equal to negative n, which is 500, times your d flux dt, which is going to give you V is equal to negative 0.9 cosine of omega t, or cosine of 3 times 10 to the 6 t.
For part B, we want to find current, and so this is the equation for current, which is voltage equals to negative L over multiplied by di over dt. So we're going to take the same approach as on part A. We already know voltage from part A. So we're going to solve for di dt, and then we're going to integrate that to get the current. So di over dt is equal to V divided by negative L, which is negative 0.9 cosine of 3 times to the 6 t over negative 20 times 10 to the negative 3. Once we solve it, it reduces to 45 cosine of omega t, or cosine of 3 times 10 to the 6 t. Now we're going to integrate to get current, and after that we get that current is equal to 45 sine of 3 times to the 6 divided by 3 times to the 6. And once we solve for all of it, we'll get that current is equal to 1.5 times 10 to the negative 5 sine of 3 times to the 6 t, or sine omega t.
So for part C, to find the frequency, we're going to have to use omega equals 3 times 10 to the 6 radians per second as given in the problem, and then use the equation that frequency is equal to omega over 2 pi. And if you take 3 times 10 to the 6 radians per second all over 2 pi, the answer comes out to 477,464 hertz. This is approximately equal to 480 kilohertz.